Hello everyone, welcome back to the fourth video of the object-oriented programming. In this video, we are going to review by together some examples about the properties of the functions in Python, and we will learn how to use these properties to write object-oriented programming. One important property of the functions in Python is functions can be used as an input to another functions. Let's look at this example. Suppose that we have a function called a square that calculates x squared, return. We can define another function called evaluate that receives func as an input and value, and finally returns func value. Here you see score is an independent function, and evaluate will use a score as an input. For example, to show you how a score can pass into the evaluate function as an input, we can write result eval equals to evaluate score of 5. Let's run this cell, then results eval will be 25. Let's go through another example. Imagine we have a function called def cube that calculates cube of the x, cube of the x, return x 3. And the other function that will use the cube function is derivative approximation that calculates the derivatives of cube at a given point. Here, if you run this cell, we want to calculate the derivatives of x3, x cubed at x equals to 2. We can write a slope at 2 equals to derivative approximation cube will be input, and x equals to 2. Let's run this and see the value of the slope here. As you see, 12 point some decimals is the results of the slope at 2. The important point here is we have one independent function like cube, like a square, that these functions will be passed to another function. These structures of the functions in Python is called higher order functions. One function at top will receive another function as an input. The other important property of the functions in Python is functions can have nested structures. Let's start by nested functions, nested structure functions. In nested structure functions, general layout of these functions are one outer function and one inner function. And important point about this structure is the inner functions are accessible inside the main function. Let's review one example here by together. Imagine we have a main function, and I'm going to use some prints to show me where I am exactly inside the function, inside the main function. If I run this cell, and then call main function, you see I am in the main function. What if I use subfunction 1? You see, we get there. We have not access to subfunction 1 and subfunction 2 from here. Yes, if we use subfunction 1 inside the body of the main function and call it there, and when we run the main function, we will have you are in the main function first, and then printing that you are in the subfunction 1. We can use subfunction 2 before subfunction 1 and to see how will be the printing. If we run this cell once more and again main function, you will see first we get this print and then subfunction 2 and then subfunction 1. Therefore, the priority of callings is a matter. Let's review another example. Imagine we want to calculate a polynomial like this. Polynomial, the inner function is calculate x, and a, b, c, the coefficients of the second order polynomial are given as an input to polynomial. And there is another function called calculate that will receive the value of the x. And finally, returns the value of the calculate function. We can run it like result poly equals to polynomial, and let's write 1, 2, 3, a simple one. Now we need value of the x. We can run result polynomial, result poly with x equals to 2. You see, the result is 11. Another example about the nested functions that we have outer function and inner function could be an example like this. Make power. The inner function here is def power, which returns x power to n, and the final return value is a power. Here I want to calculate a square and cube. How? I want to write a square here equals to make power two square Again, rerun. See, the value of the score will be, for example, 416. At this cell, I introduced 2 as value of the n, and at the next cell, I introduce x, 4 power to 2. 4 squared equals to 16. And in the next cell, I want to calculate the cube. Cube equals to make power, and I will just change it to change 2 to 3. Yeah. If you write cube of 5, the result will be 125. These important properties of the function let us to call them first-class objects in Python programming. I think by these examples, now you are well prepared to learn more important concepts in object-oriented programming, which is decorator functions. I will delete extra informations here, extra cells to start decorator functions. Decorator functions. In decorator functions, we have inner and outer functions. Imagine you have a function like decorator, def decorator function. It shows that the decorator receives an input, a function as an input, and we have a wrapper part that prints before, prints func, and prints after, and return wrap. At the next line, we have a function called greeting, which prints hi, how are you? If it write greeting itself, if it execute greeting itself, it tells us hi, how are you? But if we pass greeting into the decorator, like result greeting, a new parameter, decorator. I just want to make sure that decorator is written right, and then greeting as an input. Now print it. Result greetings here. When decorator passes the result greeting becomes a function itself. Look, you remember when I was printing the greetings itself, the output was hi, how are you? But after I passed the greeting inside the decorator, the behavior of the greeting function is changed here. You see, it is written before, hi, how are you? And then after. Something before is written and something after is written. Decorator functions receives one function and changes its behavior. Is a general definition of the decorator functions. By some examples, I hope you learn this concept very well. Let's go through another example here. Imagine we have again, function called a square that returns a square of the x and another function called mass exercise that receives one function as an input, and in this example we received a square as an input, and then wrapper part is x, result would be func x plus 3. And then I will ask the Python to show the results like this print to me, and then I will return wrapper here. Yeah, we need to put wrapper here because this mass exercise should return a value. Let's see how it works. First, run this cell. We know that if we run a square 2, result is 4. Behavior of a square function is calculating the square value, a square of any value that receives as an input. But when we pass the square into the mass exercise, let's see what will happen. We define results math equals to mass exercise and a square as an input. If we now use 2 as an x, here x will be replaced by 2. We get this print that at x equals to 2, the created result is 12. A square of 2 is 4, and 4 will be summed with cubed of 2, which is 8. 4 plus 8 equals to 12. What if we run result math for 3? At x equals to 3, the created result is 36. You see, behavior of a square is changed by passing it into the mass exercise. But we can write the created functions simpler than what you see, what we discussed here. You see here, manually I write result mass equals to mass exercise equals a square. I just copy this cell, paste it here to tell you how I can write it simpler by just adding at mass exercise. Now a square is not the square that you see here. Just run it once to see what do I mean. A square of 2, behavior change. You see, by writing at mass exercise at top, the behavior of a square is completely changed. But how can we use decorator functions in object-oriented programming? These examples that we reviewed today hereby together, the first example was about how passing one function as an input to another function. The second one was nested structures of the function. And after that, we introduced the decorator functions. And now the question is how we can use decorator functions to write the object-oriented program. From previous video, you remember we wrote a program for database of the company. I will bring up this example again to see how we can develop previous program by decorator functions. This program is from previous video. As you remember, we were introducing employees to the database of the company, and the employees had the bio information like age, like name, and they had an employee ID, they had years of experience. And at the next step, we wanted to understand, do these employees have received loan from company or not? You remember by magic method that we defined here, we introduced all of these instances. We constructed all of these instances, and the name is age, email, employee ID, which are attributes, are introduced simply to the database. And also, we make the job simple. We said we can write information of employees in very abstract, just in one line, and by writing name of the class, company staff, employee number 1, employee number 2, and etc. can be added to the database. It is a general general discussion that we had in the previous video. But some important issues that I discussed previous time was discussing the instances, the method instances like self loan amount, like self has loan, and class instances. If you remember, I said by writing the self dot and the attribute, we make the instance for the method, and these instances are accessible to the whole body of the class. And also you remember this parameter amount, that no self is written at the left side, and this make it very specific parameter that can be accessed just inside the get loan information. And at the end, I introduced counter as a class instance, as an instance which is written for the class. And because it is for the class, we should use the name of the class before the counter. What is the task of the counter? The task of the counter was when we start the database from scratch, no employee exists, no employee information exists in the database. Therefore, we consider the counter equal to 0 by adding the employee number 1. The counter value will be changed to 1, and by adding more, this counter value will be added 1 by 1, and it is increasing. One of the applications of decorator functions is they make us enable to change the class instances. How we can change the class instances? Why we need to change the class instance? For this example that we reviewed last time by together, imagine we need to, we do not start the database from scratch. Imagine there are 100 employees, information are existing in the database, and this counter therefore will not be 0, will be 100. And we need to start from the 100. How can we change this class instance? To change the class instance, we can simply use the decorator function by just adding the add class method here, and then define a function counter plus. What should we write here inside the bracket? We know that we want to introduce a new value, but this function will not be similar to the previous ones that are using self. Here we use CLS because this instance, we want to change the class instance. We use the CLS to show it belongs to the class. The class itself, the word of class is reserved for Python. We cannot use a class, but CLS, it is a word which is agreed on, and programmers use the CLS and a value, a new value that we want to add. Then we will use to reference the parameter, we use CLS counter will be value. Okay, let's run this cell. Yes, it suffers from a comma here. It's true. Yeah. And see add more. We want to change the value of the counter here. The previous value is 0. We want to change it to 10. Name of the class, we call it class dot counter plus $10. Cool. Then we can now check the value of the counter. Dot counter is 10. But before running this part, maybe it's good to run it once with and without this part. If we run this class once more and then call it company staff dot counter company staff counter is not defined. Okay, because the higher case C is required. Company staff counter is 0. And let's add our function here. We want to change the class instance by this function. And then we want to check the counter again. We see it is 0. Here we are adding a new value to the counter, this value. If we run it, again check the counter value, we see it is 10. So this is one of the applications of the decorator functions. Another applications of the decorator functions is making alternative constructors. Previously, we constructed some instances, as you see here, with init magic function. And how we can make alternative constructors, we can start by an example. Do you remember previously we were adding employee information in this way to the database: employee 1, employee 2, employee 3. But what if we receive employee number n, employee number n, and with this information, with string information? Here you see all information: employee number n, name is John, 30 years old, this is his email. Employee ID, 8 years experience, and has received loan from the company. If we receive the string like that, then how we can add it to the database? The solution for this is we just can write, can use split functions of the Python. We can write employee number n equals to info equals to dot split and yes. One space in between. Then if you write employee info, you see they are separated like. But we can construct one instance inside the class that it automatically performs this splitting for us by using the decorator functions. And this is how we can do it. We can again make a class method, and we will call it def read employee info. Employee info, we need to use CLS to show it belongs to the class, and input a string. One point about this CLS, we can use other words. So even we can use self, but we in the long programs, in the complex programs, it will make confusion. Then how we can understand it belongs to the class or not? That's why CLS is an agreed word that we use for the methods, for the method that we write for the class. CLS input a string, then we can write it like this and return value. Okay, let's run this cell and see if we introduce one string, how this alternative constructor that we wrote here can help us to split it to the separated information. We can add more cells to see that new employee or new employee was employee number n. Employee number n equals to name of the class was company staff, same name, company staff dot read employee info. Read employee info, and employee N was input. Now let's see how we can access the data. We have received one string, and we expect this alternative constructor that we wrote with this method help us to split it to the separated information. Now we can say age, 30 years old. We can say email, john@gmail.com. Another application of the decorator functions is to write static methods. What are static methods? Static methods are methods that may be not directly related to the tasks that the class should do, but it will add some supplemental information to the database. For our example, you remember we needed to add the employee information to the database. But knowing that, because these employees, let's say they drive to the work and they park the car in the garage or in the parking spots that company have provided. But knowing that if they park the cars in the garage, either any free spot in the garage or not, will not be part of the database, but we provide some type of supplemental information for the company to know how much free spots remain for the visitors, for the guest visitors that will come to visit the company. Let's add this part also to our class. And we said add a static method. For the static method, we can have something like a staff parking, or maybe available parking info. The parameter is parking spot I want to use one if statement. If, for example, let's say if we have spots less than 4, it will be announced that all parking spots are occupied because we need 3, 4 for the visitors. Just assumption. Let's write if parking spot, this parameter, if parking spot is smaller than 4, then print for us in the screen that all parking spots are occupied. Close the bracket, else means bigger and equal to 4. Then we can say print some parking spots are available. As you see, this method necessarily is not directly related to the database, but gives some information, some supplemental information by using the database information. I hope you have enjoyed this video also. In this video, we have reviewed some important properties of the function, and then I introduced decorator functions, and then we learned how to use the decorator function to change the class instances and make alternative constructors and make static methods in Python.